Hi, in this problem we're going to do a sort of a classic related rates problem where what we have is a ladder that's leaning against the wall and the ladder slides away from the wall. And well, the way it's set up is that the top of the ladder is sliding down the wall, and because of that, the base of the ladder will slide away from the wall. So, okay, so it's a 10-foot ladder. Let me just write here that that's 10. And it's leaning against a vertical wall. And the result is that we have this right triangle. Now, what we're doing here, what's going on is that the top of the ladder slides down the wall. And what we do is we see that there's a right triangle, and we label the length of one of the sides as y. You can pick a different letter. I'm going to pick y just simply because it's vertical. And then I'm going to call the base of that as x. So the base will move away from the wall, and while that's happening, the top of the ladder is moving down the wall. And so we're given, all right, and it says if the top of the ladder slides down the wall at 2 feet per second, how fast is the bottom moving along the ground when the bottom of the ladder is 5 feet from the wall? So here's our, you can, if we feel like we need explanation, that's the wall, and that's the ladder. All right, so what we're given then is, when I put this in calculus words, and is that y is the y, which is the length of that vertical side of the right triangle, is shrinking. And so it's shrinking over time, so we write dy dt. And the rate at which it's shrinking, or the rate at which it's decreasing, is 2 feet per second. So in order to show decreasing, I write -2, because when a variable is decreasing, the derivative is negative. And what we're trying to find is the rate of change at which x is increasing, which I'm just saying it's increasing because we can see it. If y is moving down the wall, if the top of the ladder moves down the wall, the base of the ladder should move away from the wall. So x would be increasing, and therefore the derivative, we should have a positive derivative. And we're trying to find dx dt at the moment when x equals 5, which means that the base will be 5 feet from the wall. And we have this equation or formula which ties together x, y, and 10, and that's simply using the Pythagorean theorem. So we have the Pythagorean theorem, which gives us x squared plus y squared equals 10 squared. So, all right, let's go ahead and move on. And what we do in these related rates problems is we find a formula that ties in all the variables, and then we take the derivative with respect to time. So I have ddt of these variables, which are considered to be functions of t. So I have ddt of x squared. Well, x is not the same as t, but we're assuming x is a function of t. And when we take that derivative, we use the chain rule. So you take the derivative of x squared with respect to x and write 2x, but then multiply by the derivative of x with respect to t. And we just move along and do that all the way through. The derivative of y squared is 2y dy dt. The derivative of a constant is 0. Then we get a little bit of cancellation by dividing through by 2. Now, what I need to do is I'm going to put in at this point, after I take the derivative, then I start putting in numbers. I'm going to put in x equals 5, because we're trying to see what happens exactly when x equals 5. I'm going to put dy dt equals -2. And what else am I going to put in? Well, I mean, let's keep in mind what I'm trying to find. I'm trying to find dx dt when x equals 5. So what else do I need? Oh, I need to find out what y is. Okay, and put y in. So let's go ahead and find y when x equals 5. And we can simply do that by using that formula or equation that we have, that we wrote down. We have that x squared plus y squared is equal to 10 squared. So here I'm drawing a little picture here. Now, there's also another way we can do this. It's just a little more clever, but it doesn't really save that much time anyway. But we're trying to find y, so I have 5 squared plus y squared equals 10 squared. So y squared is going to be 100 minus 25. So y squared, or y, will equal the square root of 75, which is radical 25 times radical 3, which is 5 radical 3. Now, if you notice by drawing this picture that it's a right triangle and that one of the legs is half of the hypotenuse, that means it's going to be a 30, 60, 90 right triangle. And the ratio then you'd have 5 as half of the hypotenuse 10, and then the other side would have to be the shorter leg times rad 3. So you could compare this to a 30, 60, 90 triangle, but it doesn't really save that much time anyway. So maybe you don't even want to even think about that. But okay, so we have that little piece there that we're going to plug in. So we're going to fill in to our equation, and also at the same time, I really need to think better about space here. Okay, so I want to get all on one page, I think. All right, so I'm going to fill into my equation that I have here, which is x dx dt plus y dy dt equals 0. What am I filling in? I'm going to fill in x is 5, because that's one of the things that's given. Or it's not really given. It's given that we're trying to find dx dt when x equals 5. Then it's going to be times dx dt. And then we found out when x equals 5 that y equals 5 rad 3. And then dy dt is constant, which is negative 2. That was given. Equals 0. Then I can do a little tiny canceling and cancel out these 5s. And then what we can see is that we find our answer. Except what I'm concerned is that I'm running out of space. Okay. So we get that dx dt is equal to 2 rad 3 feet per second. So that means that the ladder is moving away from the wall at 2 rad 3 feet per second. So let's write a sentence to make it seem even better, to improve what I just did there. The ladder moves away from the wall at 2 rad 3 feet per second. Now, some people would like an answer that's a decimal approximation. So let's just do a little remark that according to the calculator, 2 rad 3 is about 3.14. Sorry, that's not it. I was thinking about pi or something. 3.46 feet per second. That's just using a calculator, and you can even check that using the. Hey Siri, what's 2 times radical 3? All right, okay, so 3.4641. So I decided, for whatever reason, to round to the hundredths place. But you can do whatever rounding you want, because I'm giving you the exact value here. All right, this is not a problem special to Openstax. This is a classic related rates problem that you're going to see in any calculus book. All right, so you're going to get this in any calculus book. I highlighted a few things along the way, but the final answer there is the one in yellow highlight. All right, so that's all.